Good afternoon. We're going to do a little bit of an introduction into the simple harmonic motion laboratory that will be conducted for General Physics 2. In your chapter, as we get started in General Physics 2, we are normally going to be doing something called simple harmonic motion. And simple harmonic motion is going to be repetitive motion, and I'm going to go ahead and call up your book so that you can actually see the equations that we're going to be dealing with. So this is in chapter 13 of the Searway and Jewett text, but we're actually going to be looking at the motion of a pendulum as simple harmonic motion. Some key things that you want to look at when you're doing this is you want to kind of go in and review the overall pendulum. So I would recommend that prior to coming into lab or prior to starting the lab, you're going to actually look at this particular section of your textbook. You'll want to come in and look at some of the assumptions that are being made. For example, we're going to make an assumption associated with the angle. In this lab, you're actually going to compare doing larger angles. And this is a real critical point. We're looking at for when we derive this equation for the simple pendulum, we're looking at the sine of the angle. So when you're doing your experiment and you're doing 3 different angles, you want to make some observations about what it is you're seeing. Then once we do that, we've made an assumption, and we want to test out that assumption again by doing it experimentally. So we go through all of this and remember that we're dealing with angular frequency when we're dealing with simple harmonic motion. And you'll see that in the lecture portion of the class where we're looking at the motion around a circle, we're looking at a complete cycle, and we can look at it by a bouncing spring, our pendulum going back and forth, or by a bead going around a circle. But when you do that, you're going to find that your angular acceleration is related to the acceleration due to gravity and the length of your pendulum. I want you to kind of look at this again because this equation right here, you're going to explore as part of the laboratory changing in mass. And all of a sudden, what we see in this equation is that that changing mass goes away. It really isn't going to have a difference. But we don't know that, and when we do it experimentally, we want to verify that, yes, this model is correct. And so now you get to the period of the simple pendulum is related only to 2 pi times the square root of the length divided by g. You're going to have to manipulate this equation so that when you graph your data in this experiment, you're going to be able to get a straight line and see what's going to happen. So you're going to be looking at developing a graph where you want to come up with a straight line or you want to come up with something so that when you graph it, you're going to be able to see the acceleration due to gravity right from your graph. And that is going to be a graph that's involving the period and a graph that involves the length of your pendulum. So let's go back to our laboratory so that you can actually see the lab and where we are. Oops, I went to the wrong window. But here is your view of Blackboard Ultra. And you can see in here that I have the Simple Harmonic Laboratory as a module. So we've got that module there. When you click open the module, you're going to see 2 different laboratories. You're going to see the reference laboratory by myself, and you're going to see a simple harmonic laboratory generated by ChatGTP, as well as where you're going to turn in the lab. So one of the things you're going to want to do is you're going to want to open our reference laboratory. And when you do your laboratory memo, you're going to want to make sure that you reference the appropriate documents. So in this laboratory, there's some pre-laboratory exploration. Again, it's kind of going back to looking at that section of your book to verify where you are in that section of your book. And there are a couple of questions I want you to think about prior to starting that lab. So we're going to the physical constant we're going to predict, I'm going to tell you right now, is the acceleration due to gravity. In this experiment, for those of you that are doing it in the laboratory itself, I have string, I have masses, but if you're doing this one at home, you'll want to use a piece of string or thread. You'll want to be able to measure the length of your simple pendulum. You'll want to be able to put different masses, so you can use a washer, nuts, screws, and you want to do different variables. You want to use different weights to have or different masses at the end of your string. You can use your smartphone to do your measurement of your period. My recommendation is to do 10 complete cycles before you determine your period each time. And you're going to do 3 repetitions. Remember, that's 3 repetitions of each of these various items. When you do the experiment, if you think ahead a little bit, you're going to be looking at 3 different variables. We're looking at length, we're looking at period, and we're looking at mass, and we're looking at the angle. So we're going to be comparing period to each one of these other dependent variables, the angle, the length, and the mass. Now, if you do the first one, 1 length, 1 angle, 1 mass, you can use that for the other 2 experiments. And so you're not repeating quite as many experiments. And I think I tried to describe that pretty well in the actual procedure. So you do have your procedure here. Again, you can use the FAQs. You'll see the FAQs posted in a little bit if you have questions about the laboratory, so that you can go on and get those. You have some data tables here, and you're going to need to reproduce those data tables in your laboratory memo. And you'll want to do your length. You'll want to do your comparisons of length. My recommendation, once you get through that changing the angle part of the experiment, you'll want to stay at an angle less than 20 degrees. And that'll be a question that you'll want to answer in your discussion. Why that 20 degrees? What is it about 20 degrees that's going to allow us to be able to use that assumption that you saw in the text? So that's a question that you'll want to answer. So you have those tables there, and then as part of your discussion or as part of your data analysis, you'll want to answer the questions from the reference laboratory. So this gives you a place to go, gives you those procedures, gives you that step-by-step instruction as well. So let's go back here. So that's the main overall experiment. When you do your laboratory, I am requesting one of the things that you're going to do. It's also written in the laboratory. Is this tells you the due date, but we want to click open this particular one. Okay. All right. I believe. Okay. I'm going to have to look at the details and information, and I will post these in another spot because for some reason it's not showing up the way I expected it to. So I will make sure that that is actually posted. So let me go to a different spot. Actually, what I can do, I think I have it all. Okay, let me go to I'm going to exit the student view. I'm going to add this to the laboratory. So I'm going to add a document. There it all is. So it's already in there, and I'm going to hit save, and we will go through this. So this is the information that I thought you would see in your assignment when you opened up that assignment. But here it is. You're going to perform the laboratory as outlined in the laboratory document. You're going to develop the laboratory memorandum using the template that has been provided. And just as a reminder to everyone, your templates, and I'm going to make sure this is visible. Your templates you can find in the tools and resources portion. So you have that, and there is the laboratory memo template, and that's the template that you'll be using for this laboratory. And when you do that, this is what I've kind of had detailed here. In your graph and data sections, you're going to have those tables reproduced. If you're having trouble making the tables, please make sure those are listed. You've got some references here. If you're in the procedure section, you want to provide a general outline. You don't have to rewrite each of those steps, but you want to be able to describe it such that somebody understands what it is you're doing. In your analysis section, you need to answer some of the questions that were in that discussion at the reference laboratory. I do want to see these items that are in there. You'll want to do comparisons of your acceleration due to gravity based on the known value that we talk about in our textbook. You're also going to want to do it using an internet resource where you can get that for the location of Enid, Oklahoma, Stillwater, Oklahoma, or Tonkawa, Oklahoma. Or if you're in Pawhuska or somewhere along the way, that's when you do the experiment. You want to be able to have that. You can use your 5-FOX application to determine the acceleration due to gravity. And then I want to have those observations of the video analysis. So the one video, you're going to do 10 complete cycles using your longest length and using that angle of less than 20 degrees. And I want you to create your equation for your simple harmonic motion using the video analysis. And your video analysis tool is in the tools and resources. In your discussion section, you want to highlight these items here. And finally, if you're using a laboratory partner, everyone is responsible for their own laboratory memo. But if you're using a partner, you definitely need to reference who that partner was or partners in your resources section so that you can have that information. So you will have that here in the document. I'm going to go ahead and edit this. This is what is expected in the laboratory memo. So now you have that as well. And again, there'll be some frequently asked questions. If you have questions or you're having trouble with the experiment, you can contact me or you can post it in the frequently asked questions so that you have that. Just again to point out a couple of other places here. You want to make sure in the tools and resources, if I click open the tools and resources, there is your application to the 5-FOX application. There is the video analysis tool so that you have that. I've put some other templates that are there for you so that you can actually reference a few things that are in there. The laboratory is worth 50 points, and you should be able to see the grading rubric associated with the laboratory. So there, the assignment content is there. I'm not sure again why it wasn't coming up on the other one, but I've got it in a couple of other places. It is an assignment in this one, and then you're using the laboratory grading rubric. So hopefully that will get you started for this laboratory. You'll have this video as a reference, and we will see you next week.